Hi students, today we're discussing about an important concept in chemical bonding and molecular structure. So in chemical bonding and molecular structure, so one of the important concept for this competitive examination level, so that is about especially of the determination of hybridization. So what is about the concept will be determination of hybridization and shape of molecule or ion, the shape of molecule or ion having single center atom. So that means here the center atom is only one. For those who are going to use this method, so determination of what? Hybridization, as well as called as the shape of the molecule or ion having single center atom. Now, if you take this the number of electron pairs, because you know that according to this valence shell electron pair repulsion theory, the shape of the molecule depends upon what? It depends upon the electron pairs only. So then, original shape of the molecule depends upon whether the electron pairs are bond pairs or lone pairs. So that means here it depends upon both bond pair as well as called lone pair. So that's why we have to take this the total electron pairs. Now here this will be going to get us called as this hybridization value. Half of V plus M plus A minus C is the formula. So that means here is called. So half of V plus M plus A minus C. Sir, what are the V stands for, M stands for, A stands for, C stands for, means here if you see here, the V stands for the valency of the central atom in the compound. So valency electrons, it will be generally equal to this, what is called as the group number. The next one will be known as called as the M will be number of monovalent atoms bind to the central atom. Number of monovalent atoms bind to central atom. Then we have the one C will be called charge of cation. So that will be simply called so positive charge. The next one will be known as called A, charge of an ion. So we know that it is of negative charge. The next one, if the bonded atoms are, what are this? Hydrogen, fluorine, chlorine. So which are going to call monovalent atoms, then each one contribute only one electron. So this means these will be known as called, so like this, hydrogen, fluorine, so chlorine. These are what? Monovalent atoms. So these will be going to call as what? Monovalent atoms. If the bonded atoms are like oxygen and sulfur, then each one contribute how many electrons? The 2 electrons. So that's why this oxygen, sulfur. So these are called divalent atoms. Divalent atoms. Because this must know, one must do, if you want to write this hybridization as well as called shape of molecule, one must know about what is the monovalent atom, what is the divalent atom. Now, if you move on to this, the one number of electron pairs will be 2. So by this what you can say, the shape of this hybridization will be called sp, 3 will be called sp2, 4 will be called sp3, 5 will be called sp3d1, 6 will be of sp3d2, 7 will be of sp3d3. So once you know this the number of electron pairs, then we can easily identify this the hybrid orbitals formed by this element. Now if you move on to this example, the first example I am taking called xenon oxy tetrafluoride. So what is an example? Xenon oxy tetrafluoride. In xenon oxy tetrafluoride, what is the central atom? First point you have to identify. The central atom will be of what? Xenon. Then xenon belongs to which group of the periodic table? So it is of 18th group. That means the valence electrons will be 8. Now if you apply a formula, what you can write? Then electron pairs will be numerically equal to what you can write? Half of. This will be known as called valency. Then number of monovalent means fluorines. How many fluorines are there? 4 fluorines will be there. This is about the one. The molecule is said to be neutral. That means it has no charge. -0 plus 0. That means here 8 plus 4 will be of 12. 12 by 2 will be called 6. The 6 indicates the hybridization is what? It is of sp3d2. The 6 indicates called as hybridization will be called sp3d2. But only hybridization not going to give the geometry to the molecule, because already we discussed that the shape of the molecule depends upon bond pairs as well as called lone pairs. So here hybridization not directly give the geometry to the molecule. Here the lone pairs can be getted as called. So what is the value? It is 6. 6 minus, then monovalent species will be called 4, then divalent oxygen will be called as a 1. That's why the number of lone pairs will be called as a 1. If a molecule is said to be having a hybridization of sp3d2 with how many lone pairs? So 1 lone pair, the structure will be of square pyramidal. So it look like a structure, xenon, then it is of double bond oxygen. So we have the 4 fluorines in the square plane and said to be having 1 lone pair. So this is about known as called the lone pair. So this is about the structure regarding to this xenon oxy tetrafluoride. Now if you move on to the second example, PCl6 to the power of minus, PCl6 to the power of minus. So first of all, identify the central atom in this one. What is the central atom? Is the phosphorus. So phosphorus means here we know that the valency will be called 5 because the phosphorus belongs to 15th group. Then how many chlorines bind to the phosphorus? 6 chlorines. That's why 6. And it is having a minus charge. That's why it is called minus 0 and plus 1. So that means the total value once again 6. The 6 indicates what is the hybridization. Once again it is of sp3d2. Now the lone pairs. So here the value will be 6 electron pairs. Then monovalent species also 6. No divalent. So that's why 0. So if molecule will be sp3d2 with 0 lone pair, then the structure will be called octahedral. It look like a structure simply. Phosphorus, chlorine, we have the simple. Just like called as a SF6, but the overall molecule is said to be having a charge of minus 1. It is about called PCl6 to the power of minus, having octahedral structure. Now if you go to this another example will be known as called as a third one. So the I3 minus ion, which is a molecular ion. In this I3 minus ion, one must remember out of 3 iodines, 1 will become as a central atom. Then remaining 2 will be called bonded atoms. So by this you can say the iodine belongs to which group of the periodic table? 17th group. That's why valence will be 7. Then plus the another 2 iodines will be going to bind to the central atom. That's why 2 will be monovalent. And because of negative charge, we have to take plus 1. Then the value will be called 5. The 5 indicates the hybridization is what? sp3d1. Then the number of lone pairs, if you want to find out the 5 minus 2 minus 0, that is called 3 lone pairs. The 3 lone pair means the structure will be of what? So linear, and it can be written as called simply the central iodine will be binded to 2 terminal iodines in a straight chain manner, and this the middle iodine said to be having especially of 3 lone pairs. Then these are also having the lone pairs. So it look like called as simply called as a linear in structure. So this is about the information regarding to this, the identification of the shape of the molecule and the hybridization with the help of this the general formula which is discussed so far. Okay. So thank you. So this is about this today's concept.